guys, hi everyone, welcome to Easy BTech. Today I will teach the E.M.F equation of a DC generator. So when the E.M.F is induced in a coil, when the conductor is rotating in a clockwise direction, it will cut the flux and E.M.F is induced. According to Faraday's law, where induced EMF is equal to minus n into d phi by dt. This minus sign is according to Lenz's law. Lenz's law. And n is called the number of tons. But in this EMF equation of a DC generator, n is replaced with t. So t represents the number of tons. The average value of induced EMF per conductor is equal to d phi by dt, where d phi is called the change in flux. And dt is called change in time. So if you observe, for a two-pole machine, how many cutting actions will be takes place? So if you observe this waveform, the maximum peak will be attained s at pi by 2, and then negative peak will be attained at 3 pi by 2. That means maximum peak is attained at the center of the north pole, and negative peak will be attained at the center of the south pole. Suppose if you take a four-pole machine, again two cutting actions will be takes place. So this is the maximum value of induced EMF, positive portion, and negative portion is like this. For a two-pole machine, 2 times flux cutting action takes place. For a four-pole machine, 4 times cutting action will be takes place. Cutting action takes place. If you go for a p-pole machine, how many times cutting action will be takes place? That is d phi is equal to p into phi. N revolutions are made in 60 seconds. For one revolution is how much? The time is dt is equal to 1 by n into 60. That should be equal to 60 divided by n. Substitute the average value of induced EMF per conductor is equal to phi into p divided by 60 by n. That should be equal to 5p n by 60. And the average value of induced EMF is also depends upon the number of parallel paths. The average value of induced EMF is equal to, the conductors are represented with Z. If it consists of Z number of conductors, multiply it and 5p n by 60 into Z. And one more term is missing, that is inversely proportional to the average value of induced EMF is inversely proportional to parallel paths. So now your overall generated EMF equation 5Z by 60 into P by A. I will tell you how The generated EMF is inversely proportional to number of parallel paths. I am taking a 4 coils. Each coil voltage will be 10 volts. Each coil voltage will be induced voltage is 10 volts. And each coil carries a current of 1 ampere. And here also I am having 1 ampere. I am connecting the two coils in series, and another two coils are also connected in series. Now what is the voltage? So this is 10 volts, and this is also the voltage across the another coil is also 10 volts, and each coil is 10 volts. The current flowing through this one is 1 ampere. The current flowing through this one is also 1 ampere. If you apply KCL at this node, the total current is 2 amperes. So the total voltage will be, so if you observe, the 10 plus 10 is 20 volts. Suppose if all the coils are connected in parallel, what will happen? Each coil carries a current of 1 ampere. So now if you apply KCL, this one 10 10 10 10 is a voltage. If you apply KCL at this node, the current is 4 amperes and the voltage is only 10 volts. So if I am connecting all the coils in series, the voltage which is appeared across the series combination is 40 volts. Each coil carries a current of 1 ampere. Let us check it. In the first case, 40 volts 1 ampere. In the second case, the current is increasing, voltage will be decreases if the number of parallel paths increases. In a third case, if number of parallel paths are increases, then the voltage is decreases. See, number of parallel paths increases, then generated EMF is decreases. That's why, as I said, Eg is inversely proportional to number of parallel paths. So Eg is the generated EMF. Your finalized equation is phi Zn by 60 into P divided by A. Phi Zn by 60 into P divided by A, where P is the number of poles and A is the number of parallel paths, and Z is the number of conductors. So one turn is equal to two conductors. And N is the speed of the armature in RPM, that means revolutions per minute. So your overall generated EMF equation is equal to phi Zn by 60 into P by A. So this is the one problem. A 4-pole lap wound DC generator has 90 slots and each slot has 6 conductors. So if you take a DC generator armature and the slots are like this, so total number of slots is 90. In each slot 6 conductors. Yes, in one slot 6 conductors, second slot is 6 conductors, and in 90th slots also 6 conductors. So total number of conductors is equal to slots into slots into six conductors, six conductors per slot. Slot will be cancelled. Yes, then you will get the total number of conductors. How many slots are there? Yes, 90 slots are there into 6 conductors per slot. So 90 into 60, that should be equal to 540 conductors. The Z value is 540 conductors. One more thing, in a generated EMF equation, 5Zn by 60 into P by A, where A is equal to P for lap winding and A is equal to 2 for wave winding. So in this problem, if you observe, what is the number of poles is? The number of poles is 4. The number of poles is 4 and the speed of the armature or the generator is 1500 rpm. The question is find the EMF induced. Yes, E is generated EMF is how much? And the flux per pole is 3 milliweber. Flux per pole is 3 milliweber. So 3 into 10 to the power of minus 3 Weber. So substitute all the values in generated EMF equation. So 3 into 10 to the power of minus 3. The number of conductors is 540 into 1500 divided by 60 into 4 by 4. Why? Because it is a lap winding. So 100 will be cancelled. 690 is a. So what is your answer? Tell me, the students. 3 into 90. So 270. Yes, 270. So 270 into 10 to the power of minus 3 into 150. So two zeros is cancelled and 27 into 15 is how much? 5 7 ja 35, 5 2 ja, so 27, so 405. So the generated EMF for this problem is 405 into 10 to the power of minus 1. Why? Because 10 into 10, 10 square. 10 square into 10 to the power of minus 3 is 10 to the power of minus 1. So your answer is 40.5 volts. This is the generated EMF for this problem. So go to the next problem. A 6-pole wave-wound DC generator running at a speed of 300 rpm. So here 6 pole means number of poles is 6 and wave wound. So wave wound means number of parallel paths is equal to 2 and running at a speed of 300 rpm. 300 rpm generates an induced EMF of Eg is equal to 535 volts. Calculate the flux per pole is equal to how much? If it has 650 conductors, this is our question. What is the unknown quantity? Is unknown quantity is flux. We know the equation Eg is equal to 5Zn by 60 into P by A and substitute the values. 535 is equal to 5 is the unknown quantity where Z is a 650. You can substitute here. The speed is 300 rpm divided by 60 into number of poles. The number of poles is given as 6 by 2. This step is very important. Most of the students, they should commit a mistake. Instead of substituting 2, they may be substitute 6 by 6. Remember one thing, for wave winding the number of parallel paths is 2, for lap winding the number of parallel paths is 6, and phi is equal to, so 2 3s are and 65, so then flux is equal to 535 divided by 650 into 15, that value should be equal to 58.472 milliweber. 58.472 milliweber. So coming to the next problem, the armature of a 6-pole DC generator, yes, the number of poles is 6 and having number of conductors is 650, generates an induced EMF of Eg is equal to 536.25 volts, running at a speed of n is equal to 300 rpm. The flux per pole is 55 milliweber, means 55 into 10 to the power of minus 3. So most of the students also, they should not sub applying the formula exactly, and also instead of writing 55 milliweber, 55 into 10 to the power minus 3, they substitute the only the value is 55, then you will get the wrong answer. Listen students, phi is equal to 55 into 10 to the power of minus 3 Weber, and Eg is equal to phi Zn by 60 into P by A. Check that lap winding or wave winding by solving this problem. If A is equal to number of poles, then we can say that it is a lap winding. If A is equal to 2, then we can say that it is a wave winding. What is the EG? 536.25. So phi is 55 into 10 to the power of minus 3. Number of conductors are 650 and the speed is 300 divided by 60 into 6 divided by A. I think this is 10 3. So after that 10 and 6 10 ja 10 30 ja, okay, and 1 2, so then you got the answer is 2. Number of poles are 6, but I got it number of parallel paths is 2. Tell me students, what is this? This type of winding is called wave winding. That means simplex wave winding. So that is answer. So in most of the problems, in some problems, he may ask a speed of the armature and speed of the generator with the given values of generated EMF, flux, number of conductors and number of parallel paths and number of poles. Okay, with this, the EMF equation of a DC generator is successfully completed. So once again, listen guys, the induced EMF according to Faraday's law of electromagnetic induction is equal to minus n into d phi by dt. Minus is according to Lenz's law, effect will always opposes the cause, and n is the number of turns. Here n is replaced with t. Average value of induced EMF per conductor is equal to d phi by dt. For a two-pole machines, 2 times maximum cutting action will be takes place, and the maximum value of induced EMF takes place 2 times. For 4-pole machine, 4 times. For a p-pole machine, p into 5. So if n revolutions are made in 60 seconds, for 1 revolution is how much time? Then dt is equal to 60 by n. And substitute here, average value of induced EMF per conductor is 5pn by 60. And if it consists of z number of conductors, multiply on the right side. The average value of induced EMF is equal to 5pn by 60 into z. And one more term is also there. The generated EMF is inversely proportional to number of parallel paths. By giving this explanation, your overall generated EMF guys in nature.